example 6, find the term of 2x minus 1 cubed to the 12, which contains y to the 15. So my goal is to find y to the 15. Because this has two different variables in it, I'm really only concerned about the pattern of the y exponents. I still tend to write just to help me keep track of things. I'm ignoring the coefficients, but I'm going to write in at least what so I don't lose track of the counting. So this would have been 2x negative y cubed. I'm going to write this out 3 times. 2x negative y cubed. I'm going to write it one more time so that I can have a pattern with at least 3 numbers to look at. Okay, so my n value is 12, so I count down 12, 11, 10. My second term, I always start with 0, 1, 2. So x to the 12, I can put that there. That's not going to help me at all. Y to the 15 is not linked to the x value, so you're not combining terms. I don't need to worry about 2 to the 12. So I'm actually going to ignore this. So I didn't really need to put in those x values, but I like to put them there to help me keep track of what I'm doing. So 3 times 0, this is going to end up being y to the 0, which is 1, but I actually am more concerned about the pattern of the exponent. So y to the 0 is more valuable to leave it that way. Negative y cubed is going to be negative y cubed. If you forgot the negative sign, that's a coefficient. Don't worry about it. It won't matter. Ignoring the x value, this is going to be positive y to the 6. So I can kind of tell the pattern, because this is negative, is going to go positive, negative, positive, negative. So sometimes that's helpful. So then I know that this pattern is going to be increasing by 3. So if I keep that pattern going, I'm going to have negative y to the 9. And again, I don't need those positive negatives in there, but I think it's helpful. Y to the 12 would be positive. Negative y to the 15. So I actually know my answer is going to be negative. So that's the reason I put the negative sign in there. Okay, so this is 1, 2, 3, 4, 5, 6. This is the 6th term. So you want to find the 6th term. So we're going to use our combination 12, choose 5. Remember, r is 1 less than the term you are finding. Put in the first part of the term, second term. Now, r is your second exponent. So this is 5. This has to add to 12, so this is going to be a 7. 12, choose 5. You can put that in your calculator, 792. 2 to the exponent 7 is 128. X to the 7. Negative y to the 15 is negative y cubed to the 5 is negative y to the 15. All right, multiply this. So 792 times 128 times a negative 1. So you're going to have a negative value there. And you're going to have x to the 7, y to the 15. If you look in your answer, your goal was to find part of the term that had a y to the 15 in it. We have y to the 15 in it. Now, I just have a note at the bottom of this page because I know there's some questions that you will perhaps come across that says find the constant term. Finding the constant term means to find the term with no variable. So the constant term doesn't have a variable in it. This would be an exponent 0. So when you're counting your pattern, for example, you would count down until you got 0. In fact, if I go to a previous example here real quickly, this actually, not every expansion has a constant term, but this particular one would have. Had I kept counting down, I would have had then x to the 10, x to the 5, x to the 0, and that would have been the term I would have looked for.